Well, good afternoon, everybody. Thank you for attending my presentation about automate main replacement and how we approach this with a GIS solution at South Jersey Industries. My name is KyleHartman. I'm a GIS specialist at SJI. Been there for about 4 years now, and this is my master presentation. So thank you for taking the time. So a little agenda today. I'm going to introduce what SGI is as a company, what we do, a little bit about what AMR is currently, what was the goal to bring AMR from where it is now to what it will be, a little bit about how I developed the feature class schema, a little bit about the web application, some of the final ArcGIS reports that we were developing and created, and the end user benefits and the next steps that we're taking. And then we'll have a little bit of open Q&A after. So a little bit about SJI as a company. We're a natural gas distribution company. We have about 740,000 customers. Our main headquarters are in Atlantic City, Union, and Folsom, New Jersey, but we also cover the northwestern part of New Jersey, all the way from Byram, New Jersey, down to Phillipsburg. We have a lot of natural gas distribution pipe in the ground. We've been around for about 110 years or so far. A little bit about AMR, where it came from, why it's so important to the company, and why we want to update it to GIS-based technology. AMR is our leak kind of maintenance system. So we use this to basically evaluate what sections of pipe need to be replaced in replacement projects for the future based off of leak reports that are given by our utility workers out in the field. They hand these cards over to the clerk's office. The clerk's office then evaluates those cards, plugs it into these AMR reports that are on a Lotus Approach system, and then that report generates a grade, and then that will then trigger if that section of pipe needs to be replaced with an AMR replacement project report. That's this replacement evaluation sheet here. That would then get transferred up to our engineering department to develop a scope of project, the system planning group to approve that project, and then we would ideally replace that project if it's needed. But the issue with this currently is that Lotus Approach is going to be going out of service at our company very soon. So the legacy system is not going to be usable anymore. And also that some of the reporting information has not been as accurate as we would like it to be. Considering that we're geolocating our leak locations, we want to use that information to approach this geospatially and gather more of a larger scope replacement projects to basically section out, isolate pipe, and replace it in a more congruent manner. So that was kind of a little bit about the goals of why we're bringing this to GIS. This is going to be our main study area, the South Jersey Gas Territory. This encompasses Atlantic City, Vineland, New Jersey, the counties of Gloucester, Cumberland, Salem, Cape May, and Atlantic. It's a very large territory, and it's one of the most vast territories that we have in our company at SJI. So the main goal then asked from the business was simple data entry. As I always say, it's one of the great examples. I always get told they want the least amount of clicks possible when entering data. And with this application, I try to make that as much as possible for the end user to be easy for them to understand and easy to be trained on. So the way I did that in 3 simple steps. I used domains, contingent values, and immediate calculation rules. The immediate calculation rules help calculate all the point totals for the leak rating system. The contingent values allow us to, again, add those points informations. So if you enter one field, you get another result immediately for the other based off of the domain value you could choose. I also limited the amount of domains that we needed. So for example, a domain that would be large and hard to maintain is something like streets, but also not everybody wants to enter street names every single time they're creating one of these packets for cross streets and near streets. So we used a little bit of I would almost say kind of like a cheat way using the ArcGIS Smart Editor, which will be on the next step, to kind of get around that information and managing large amounts of domains. We used what the data that we had for our advantage. So a little bit about the development of the web application. Development of the web application was really the key part of this process. We want to make it simple and recognizable to our end users. So we based off of what we had. We have an asset viewer application. This is very similar to it. The AMR app, however, has a few key advantages. One being the ability to do smart editing, drawing polygon features, and then absorbing the data from the base map information into the feature class directly and allowing the end user to override that data. This is what makes the AMR GIS solution so unique. It allows the end user to have the ability to flexibly change the information while also absorbing mass amounts of information into a single data set to make their final product accurate and readable and maintainable. This was something that the business really liked and appreciated and was a major advantage for them in their future use of this packet and project. The last part of this project that was really important was the final report results. So we wanted to translate this report here into something that could be clicked with the print button. And the way that we did that was ArcGIS Reports, a new technology that we're using at South Jersey Gas and South Jersey Industries. We haven't really used it much yet, but we're starting to get more into this technology because we're getting onto the new enterprise database systems. Going from 10.9 to 11.3 is going to make this very much usable. But this is an example of one of the reports that we can generate. Notice how it's very readable, maintainable, and also has a georeference location. The improvements from the one replacement evaluation sheet to the other replacement project worksheet is evident because it doesn't require any data entry from the initial data entry process. It doesn't require to be repeated by maintaining simple data analysis from both sides to the other. And now I kind of want to show the end user experience in this short video. I'm going to walk everybody through it here. So for this example, I'm looking up an address. As you can see here, there's these A, B, C's, and those are leak locations that are in the test environment at South Jersey Industries. When I zoom into a location, we don't have any of those leaks here, but it's a good example of the cross streets. So if you can imagine that there would be leaks in this area, you would then click on an unreviewed packet, draw your basic polygon information in. From here, then you would get the automatic generate contingent value picker. And this is kind of where I was trying to explain. This information is being pulled from our UPDM, our base map information for cross streets and nearest cross streets. And all this information is then evaluated by the end user to determine what information they want to cut over. So in this example, I'm picking between install dates, actual footage, which is our measured length between pipe to pipe segment, the main size, and the cross street and nearest cross street. I can drop down the information, select what I want to select. And after this information has been inputted, I press OK, and it's automatically on the feature class. I'm adding a unique naming nomenclature that's, again, still being decided by the end user for the business, but in this example, I'm just adding a plate map number -1. Now I'm entering the leak totals into this information. I'm entering separate leak grades. Again, all this information would be displayed on the map, but for security purposes, I'm just acting like that this is actually there, just to show the process that would be done by the end user. From here, I would obviously continue the data entry process. As you can see, it's quite extensive, but from where it was to where it is, a lot of this data is automated, and we want to get it more automated in the future. Some other advantages of this is allowing us to also see public buildings. Again, from a geospatial perspective, before it would require our end users to look in multiple applications, Google Maps, Street Views, to allow that information to be shown. Now we can see that in one singular application. After all the data is entered, we will save the application, save the feature class that created the feature. And as you can see, instantly points were created. However, we're not done yet. We're going to change the status of this map, and this is going to trigger all of our immediate calculations on the front end to allow the end user to see the total points that are created. From here, we have seen that this application, this feature should be created and moved up in the process. So for this example, we're going to add in a few more fields and trigger the point totals to increase. Sorry, it's a very long process. And this then will create the basic information that you need. So overall, I think this is a good example of showing what the data entry process is like and what the end user experience would be with this application. So now the best part, where are we going? We're trying to still gain user acceptance, develop a workflow. That's sometimes the hardest part of any GIS application, is to make non-GIS users learn about GIS and understand the primary data entry process. We're still developing and posting our reports to be a print service. That still hasn't been done yet, but we will be doing it soon once we upgrade to the 11.3 enterprise environment, because we're just using the more improved ArcGIS reports technology. The last piece, which will be more of a secondary project, is we want to get South Jersey Gas to not use geocoding technology, but one day hopefully use leak survey, which our Northern company uses. And in the future, that will help improve AMR leak detection packets and allow them to just absorb the information geospatially rather than entering the information manually. There's a lot of information that's going on in this project. I understand it's a lot to throw at everybody if you're not really familiar with natural gas leak reporting technology, but that is the AMR process in a nutshell. I hope everybody enjoyed this, and let's have some open discussion about this.